everyone. So welcome back, and now we are going to have the lightning session, part 2. So all those who have presented yesterday, well and good. So we are going to host the remaining people now, and you know the motto already in 1 minute, and we're going to give you some noise if you are going beyond that time. And as usual, you have already gathered close to the dais, so good. Okay, so the first presenter is Pratik.
Hello everyone. Today I am going to present our work Attaining God Beyond Honest Majority with Friends and Foes. In standard distributed computation, malicious behavior of a party is captured in two scenarios, either in the honest majority or dishonest majority. However, in the honest majority, it is vulnerable to view leakage attack, and in dishonest majority protocols, it lacks security in the sense that it does not offer fairness or robustness guarantee. So we considered a different model that is called Friends and Foes, and which surpasses this vulnerabilities. And in this work, we give a theoretical result that necessity of oblivious transfer is required if the number of parties is less than 2t plus 2h star. Also, we design a protocol quad-squad, that is 4-party protocol, and we show its applicability in privacy preserving machine learning and for liquidity matching. So to know about this mode, please visit my booth. Thank you.
Hello everyone, my name is Abhishek. I am doing PhD in IIT Kanpur. So we started with a problem of in gym setting that the training regimes are very much focused in gym, like they are not translated to the home setting. To solve this problem, we came up with a real-time pipeline that can correct postures, and it can provide exercise specific recommendations to the exerciser. So in summary, we take an input video of an exerciser doing an exercise, and then we run that video to our pipeline. Then it classifies the exercise done into the correct form or in one of the many incorrect forms, and based on that we provide a recommendation to the exerciser so that he or she can correct their exercise in real time such that it can prevent any future mishap. So if you want to know more details, please visit us at our poster. Thank you.
Ankit.
Good morning, everyone. I am Ankit Avinav. I am from your host institute, NISER. So today I'll tell you a coffee story in a very brief manner. Let's say that after the event, you guys want to have coffee anywhere that you go, right? So what we as a host institute, we decided to put up a coffee stall at least at every one end point of the road. Moreover, the management decided that they don't have to move much, so they want a solution that is connected. And moreover, we are looking for a solution that is highly connected. So here we say n minus k is connected. So I'm talking about classical vertex deletion problem, which is NP hard problem. So you don't expect to have polynomial time solution for that. So to solve this problem, we have taken parameterized algorithm approach. So this approach says that take a line, Okay, so for most of the problem, we have shown APT result, except for one problem, SC vertex multicut problem, where we could not give an APT algorithm. Thank you.
Ashutosh.
Hi everyone, I am Ashutosh from TIFR. So many of you would have heard of at least the code on the top left, that's the Reed-Solomon code. And in many ways, it is actually the perfect code. So it is based on the idea that a degree d polynomial can be 0 on at most d places. Otherwise, it is identically 0. And if you think about it, if you find and prove the correctness of a unique decoding algorithm for Reed-Solomon codes, then you also are proving the degree maximum, which seems, I mean, we knew the degree statement for many years, but it's a way of proving it. It turns out even perfection can be extended in a couple of ways. You can add variables to get Reed-Muller codes. You can add multiplicities to get multiplicity codes. So what we do is we do this algorithm task for what happens when you extend it in both ways, add variables as well as multiplicities. So if you want to see how, stop by my poster. Thanks.
Thank you. Next is Nidhi.
Hello everyone. So imagine that you are a job seeker and you came across a job description which says that seeking relevant office handling boy and you need to do some administrative tasks. So how annoying it is to see this job description. So we all are on professional platforms and on regular basis we see such job descriptions where we don't know what exactly you are looking for. So it's as simple as moment of कहना क्या चाहते हो. So in this it is evident that we have around 65% of such job descriptions which miss mentioning job skills which are actually relevant. So I am Nidhi and I am a PhD student at IIIT Delhi and faculty at Mahindra University. So in this work we have provided a solution to this problem. So for more details please visit my poster. Thank you.
Okay, next is Anisha.
Hello everyone, my name is Anisha and this work has been done in collaboration with the AI/ML NLP lab at IIT Patna. So the poster that I have put up today mainly illustrates our work on multimodal clinical conversation summarization. And the social motivation behind this work was the increasing deficit in the number of healthcare workers and also the increasing use of internet for healthcare activities as we observed during the COVID-19 pandemic. The main contribution our work does is create a framework which diagnoses a disease and then summarizes a patient's self-report and initial symptoms and then forwards it to a doctor for primary investigation. We have also built a data set to this cause and used external knowledge for improving the quality of our summaries. So please do visit my poster so that we can discuss in details about this. Thank you.
Thank you. Next is Subin.
Yeah, we two actually came together to submit the post.
Hi.
Do you know? Yeah, please.
Hi, I'm Anju.
I'm Annapurna Valiveti from IIIT Bangalore. So do you know that if a cryptography protocol is implemented on the hardware, we can extract the secret key without while still respecting the underlying assumptions of the cryptographic protocol. These attacks are known as side channel attacks. So it will be using the characteristics of the underlying hardware to break the cryptography protocol. But there are countermeasures to defend the side channel attacks. Always the question is how efficient they are. So we came up with an approach where we will be implementing our countermeasure with 80% improvement in the execution speeds. So if you want to know more about the optimization techniques, please visit our poster. We can discuss in detail. Thank you so much.
Thank you so much.
Asif.
Good morning, everyone. So graphs which can be drawn on the plane without edges crossing are called planar graphs. So planar embedding problem is that you're given a graph and you have to decide whether the graph is planar, and if so, give an embedding of the graph. So we know that there are linear time algorithms in the sequential setting and log n time algorithm in the parallel setting. These are well known. We study this problem in the dynamic setting where the graph is ever evolving. Edges are being inserted and deleted, and we are expected to update the embedding after every such operation, which is deletion and insertion of edges. So there has been extensive work on this in the sequential setting in the dynamic model. We studied this in parallel setting, and we show that after edge insertion and deletion, we can recompute the embedding in constant time given polynomially many processes. So please visit our poster to know more about this. Thank you.
Thank you. Next is Debadrita.
So hi everyone, I'm Debadrita from IT Kharagpur. I'm here to present our work Twin SSE, which is a disjunctive SSE scheme with linear storage. So basically with the advent of cloud computing, big data, now the problem of encrypted outsourced computation is the holy grail of modern cryptography. So we look into a class of crypto primitives called searchable symmetric encryption that provisions a client with search capabilities over encrypted data that has been outsourced to a third-party cloud server. So in this work, we try to provision the client with disjunctive query capability over encrypted data with very efficient search time complexity and very low storage overheads. So to know more about this work, please do drop by my poster. I'll be happy to discuss. Thank you. Yeah. This is another work that has been done on the same topic on searchable symmetric encryption. So basically, the existing searchable symmetric encryption schemes in literature that supports conjunctive queries typically on encrypted data are classically secure. Like the security assumptions are mainly based on discrete log hard groups. So, but these discrete log hard groups are like quantum broken, basically in the presence of a quantum adversary. So, in this work, we try to find a solution to this, and we devised the first lattice-based SSE scheme that supports conjunctive queries over encrypted data. Our hardness assumptions are based on hard lattice problems like learning with rounding problems or short integer solution problems. We got some interesting results. If you want to know more about this work, please drop by my poster. I'll be happy to discuss. Thank you.
Thank you. Next is Utkalika.
Hello everyone, I am Utkalika from IIT Kharagpur. Today I am going to present on the paper titled is ProTrack, Distributed Provenance Tracking over Serverless Application. So basically we have tried to fuse both application logs and system logs to trace back the provenance of some process. So basically provenance means the origin or history of some process, and using those data, the universal log, which is created by fusing application log and system logs, we try to generate a universal provenance graph. So basically a universal provenance graph has the nodes which depicts the process or the objects of system, and the edges depicts the system calls or the timestamps or the causal order between the events. So to know more details about our work, please drop by my poster. So, thank you.
Thank you. Next is Manoj.
Good morning, everyone. I am Manoj Kumar from IIT Delhi, and I have worked on graph coarsening. So in this work, we have developed a unique and generic optimization-based graph coarsening algorithm. So this is the graph coarsening algorithm. It considers both graph metrics as well as feature metrics to do the coarsening. And for more details, you can visit my poster. Thank you.
Thank you, Manoj. Next is Nitesh.
Hello everyone, I'm Nitesh from IIT Kanpur. On the screen is our tool exist that synthesizes invariant for probabilistic programs. And so you can basically, so for deterministic imperative programs, synthesizing invariants is hard. For probabilistic programs, it is even more harder. So if you want to unfold the mystery of probabilistic programs, what are probabilistic programs, why is it hard, and what are invariants, do drop by my poster and I'll be happy to discuss. Thank you.
Thank you, Nitesh. Next is Shravani.
Hello everyone, I'm Shravani from ISC Bangalore, and today I'll be talking about our work on secure multi-party computation, which got accepted to Eurocrypt 23. So our work focuses on a setting called as perfect security, wherein broadly there are two categories of protocols. The first one, where the round complexity is dependent on the number of parties n, and the second where it's not. So in the first category, linear communication protocols were known from way back in 2008, but the second category lagged significantly behind at n power 4. So in our work, we close this gap with an improvement of n cube and give a linear communication complexity protocols with expected constant rounds. This brings in significant improvements in terms of the amount of communication and time, and which is what is visible on the slide. So do visit the poster to know more details. Thank you.
Thank you, Shravani. Shyam.
Hello everyone, my name is Shyam. This is a joint work with my guide, Professor Srinivas Vivek. So we provide, in this work, we give an attack on the, to derive locations of drivers in a ride-hailing setting using triangulation by colluding adversary riders. If you want to know more about what this is all about, please come talk to me. I'll be very happy to answer your questions. Thank you very much.
Thank you, Shyam. Next is Mohit.
Hello everyone, I'm Mohit Sharma from IISc Bangalore. My work is focused on bivariate analysis of electronic transitions using topological structures. In this image, on the top left, two fields are shown which are used to characterize an electronic transition. On a very high level, they mean amount of charge lost and amount of charge gained at every point of the molecule. And our goal was to identify those regions in red and green, which represent donor and acceptor regions, and to analyze them further. For this purpose, we utilized a variant of discrete scatter plot called continuous scatter plot and suggested two operators based on that. On bottom left, we have CSP lens operator. It takes the complete CSP as input and queries which we want to run. And based on those queries, it segments the CSPs in the desired output. The horizontal one represents donor regions, and the vertical one represents the acceptor regions. On the bottom right, we have CSP peel operator that takes extra information to segment the domain and further extract some layers of the CSP. Based on these two operators, we present interesting insights which were useful to the chemists. If you want to know that, do visit the poster. Thank you.
Thanks, Mohit. Next is Bhavish.
So, hello everyone. I'm Bhavish from Indian Institute of Science. I'm here to present our work, Shield Secure Allegation System with Stronger Security Guarantees. So, allegation escrows are systems put forth in organization to curb malpractices, harassment, abuse, etc. It requires appointing a chief vigilance officer, and the victims are expected to submit their allegation to the CVO, and the CVO is expected to notify it to the higher-ups. However, when the perpetrator is close to the CVO, there is a threat of retribution when the CVO leaks it to the perpetrator. To address these privacy concerns, we propose secure allegation escrow system where multiple distributed servers effectuate the role of CVO such that no individual servers learn any information about the allegation. And we rely on the technique of secure multi-party computation to achieve this. To know more about secure multi-party computation and my work, please visit my poster. Thank you.
Thank you, Bhavish. We have Praveen next.
Hello everyone, I am Praveen Kumar Sunsare from RCM Nagpur. This work is done with my guide from VIT Vellore. So this work is based on to detect protein secondary structure prediction. For that, the input is amino acid sequence. So in our work, we find out the local pattern of the amino acid sequence as well as long range interdependency between amino acid sequence which affect the structure of the protein. For that, we design this hybrid model in which we tune the hyperparameter with some optimizer. To know more about this, kindly visit my poster. Thank you.
Thank you, Praveen. Satyam.
Hello everyone, I am Satyam Singh, PhD student from IIT Delhi. The title of my poster is Online Piercing of Geometric Objects. This work was presented in FSTTCS 2022. In the online piercing set problem, the whole object set is not known in advance. The objects are going to come one by one, and upon arrival of the object, you have to maintain a valid piercing set by taking irrevocable decision. Surprisingly, there was a lack of study in the literature for the online piercing set problem, and we have obtained some general results for d-dimensional fat objects. To see the relation between the covering problem with the piercing set problem, the applications of the problem, and the results obtained by us, please do visit our poster. Thank you.
Thank you, Satyam. Suvi is next.
Hello everyone, I am Shubhi from IIT Kharagpur. And in this work, we have found a timing vulnerability in PyTorch's max pool operation caused by a simple branching statement. And we found that using this or exploiting this vulnerability, we can basically determine the class influenced by a target CNN model. Further, once we know these classes, we can also exploit this classifier to bypass PyTorch differential privacy and leak information about the training data being used by the target model. So we also proposed the countermeasure for this by proposing a constant time max pool operation. And we reported this to Meta as well, and they validated this leakage. So this work was presented in CHESS 2023. And for any further questions, you can drop by my poster. Thank you.
Thank you, Subhi. Vidyasagar is next.
Hello everyone, I am Vidyasagar Sharma from TFR Mumbai. This work is from UAI 2023, and in this work we work on acyclic directed graphical model where we use a DAG to represent conditional independence relation between random variables. There can be more than one DAG that represents the same set, same conditional independence relations, and such DAGs belongs to a class called Markov equivalence class, which is graphically represented by union of such DAGs. There's an interesting combinatorial problem that we have given a graphical representation of an MEC, and we have to answer how many DAGs belongs to this one. This problem becomes number P hard when we add an additional constraint called background knowledge. We solve this problem. We give an FPT algorithm, fixed parameter tractable algorithm, to solve this problem. For more detail, please visit my poster. Thanks.
Thank you. I'll just request all of you to speak closer to the microphone so that you are audible. Next is Utsap.
Morning, everyone. I'm Utshap from CMI. So this work is jointly done with Orkodev Chattopadhyay from TFN and Partho from CMI. So far now, after Neeraj's talk, you guys all know what is algebraic complexity is. So it deals with computing polynomials using algebraic operations. And the notion of hardness, which is easy or hardness, it is also there in the algebraic complexity model. And these are called VA, VP, VP, and VNP. And the inclusion in the same order. But the strict inclusion is wide open. So we come to a restricted model, which is called monotone model, where cancellation is not allowed. Thankfully, in this model, this inclusion is strictly known. But in this work, what we did is we gave sort of an unified approach to prove all these results using a same single polynomial, which is called graph inner product polynomial. We're changing the graph topology, which give you different results. So to know more, please visit the poster. Thank you.
Thank you, Utsab. Next is Yashwant.
Hi, I'm Yashwant from IIIT Bangalore. Today I'll be presenting our work which is on multidimensional persistence diagrams. So what is a persistence diagram? It is a descriptor which represents features as sets of points in the plane. Consider this example of a mountain range actually. Here there are like multiple mountains. In the persistence diagram actually, if you look at it, each of these mountains or peaks will be represented as a point, and the coordinates will depend on the height of the peak. However, to analyze, say, the temperature across the mountains, it actually varies on multiple parameters such as latitude and altitude. Therefore, we would like to develop a descriptor which captures features based on multiple parameters and not a single parameter. For this, we developed the multidimensional persistence diagram, MDPD in short. To compare two MDPDs, we also developed a distance measure and show two applications. The first is in the problem of shape matching. The second is in the problem of detecting bond formation between platinum and carbon monoxide molecules. If you find this interesting, please visit our poster for further details. Thank you.
Okay. Thank you, Yash. Next is Prashant.
Good morning, everyone. My name is Prashant. I'm from IIIT Hyderabad. My research work primarily revolves around code mixing. Code mixing is where people mix two or more languages. And this is problem of relevance, especially in multilingual societies like India, where phenomena like English, Tanglish are quite common. So, and it so turns out that this mixing of two or more languages is not really random. There are some patterns which are more preferable than others. So what we propose is a metric called SIMCOM, which sort of encodes this notion. But what is the utility of this metric? What we want to do is we want to understand if these metrics are capable enough of differentiating between a acceptable versus an unacceptable sentence. I will point you to those 4 examples. And if I ask you which sentence is okay, which sentence is not okay, I'm sure I'm going to get various opinions. So that's what we did. We crowdsourced this data, created a data set out of it, and then we tested whether these models are good enough, multilingual models or models like ChatGPT are good enough at this task. So for getting to know about more of the research, please visit my poster. Thank you.
Thank you, Prashant. Shreyansh is the next.
Good morning, everyone. I'm Shreyansh, PhD student in IIT Jodhpur. So we published a survey on biometric crypto system and their application in Computer and Security Journal. So in this particular survey, we actually present more detailed explanations about different techniques that we need to implement biometric crypto systems. And we have also Also, we also introduced a new domain that is decentralized biometric crypto system, and we also defined some potential applications in open problems. So if you want to discuss more about these potential applications and open problems, please visit my poster. Thank you.
Okay, sir. Thank you, Shreyansh. Next is Sahiba.
Hello everyone, I am crypto enthusiast and also a TCS sponsored research scholar. So our lab actually works in cryptography field, in applied cryptography with some ongoing works, and also we are exploring the post-quantum and quantum era. Not only that, we are also work in the core cryptanalysis, and this poster actually is in this core cryptanalysis field, in which I have analyzed the hash function. So if you are curious how this hash function works and how is it secure, so you can stop by my booth. And by the way, my name is Sahiba. Thank you.
Thank you, Sahiba. Preetam comes next.
Hi all. So this is joint work done with my advisor, Professor Mayank Singh. So let's say we have this unlabeled test classification data set and we want to annotate it. So ideally what generally people do is like they utilize all the annotation budget. So what if we can do the annotation with much lesser annotation budget on a condition that the performance would be the same as the maximum annotation budget. So apart from this, we have done another study like how this model performance varies as we add on more and more annotations. So to find out more, please come visit my poster. Thank you.
Thank you, Preetam. Shivani, you are the next person.
Hello everyone, I'm Shivani from IIIT Delhi, and today my poster will be about our AAAI work. So basically in a dialogue, just detecting which utterance is sarcastic might not be enough for a chatbot to understand the underlying meaning of the dialogue. So in this work, we propose a task of sarcasm explanation where we try to generate natural language explanation for the sarcasm that is present in a dialogue. While doing so, we handle multiple challenges like code mixing, multimodality, and fusing of multiple information. To see how we handle these challenges and how these generated explanation help in the understanding of other affects, do visit my poster in the evening. Thanks.
Thank you, Shivani. Aditi?
Hello everyone, I'm Aditi. I'm a grad student at IIT Gandhinagar, and my work primarily revolves around resource allocation, wherein there is a set of items which is to be divided among a set of rational agents in a way that everyone is happy, where people do not kind of envy other people. Applications of this work range from being as casual as dividing a dinner bill among a group of friends, or as crucial as dividing a set of scarce resources like vaccines among different states. In this work, which was accepted at SAGT last year, what we do is when we achieve fairness, we might have to suffer loss in the sense of collective welfare of the entire system. In this work, we quantify that loss by giving tight bounds across a range of welfare notions. I'll be happy to talk more about that poster. Thank you.
Thank you, Aditi. Sunil, you are the next.
Hello, everyone. I'm Sunil Saraswat from TIFR. In this work, which was presented last year at FSTTCS, we talk about design and regulation of exchanges. Recently, there have been several instances of stock exchanges violating trading rules. The potential reasons for these violations are ambiguous regulatory guidelines, inadequate implementation of guidelines, or undetected bugs in the matching program used by the exchanges. To solve this, we provide a robust framework to effectively and provably tackle these challenges. We provide a formal framework to specify, design, and monitor continuous double auctions, which are widely used by the exchanges. We develop a checker backed by our uniqueness theorems to detect these violations. To know more about this work, please visit my poster. Thank you.
Thank you, Sunil. Let me now invite Ranjana.
Hello everyone, this is Ranjana. So I am from IIT Ropar. So my current PhD domain is on few-shot learning for medical image analysis, and this is one of the work that got accepted in SB 2022. So as we know that in medical imaging, we do not have such a luxury of a big domain space. So that's why many techniques have come up, among which meta-learning is one. So if you want to know more about my domain, then please visit my poster. I'll be happy to assist you. Thank you.
Thank you, Ranjana. Let me now invite Dhanajit.
Hello everyone, I am Dhanajit and I am excited to present our CPR 23 paper, a probabilistic framework for lifelong test time adaptation. In TTA, we are flipping the traditional domain adaptation way of doing things. So we take a model trained in the source domain and adapt it in the test domain without the labeled data. We propose PETAL, a principled approach for online lifelong TTA. We provide a Bayesian formulation which naturally leads to the student-teacher loss, plus a regularizer that captures the posterior of the source domain data. So swing by our poster to ignite some epic discussions. Just like petals in the breeze, let your learning model soar with lifelong TTA on the fly. Thanks.
Okay. Thank you, Dhanajit. Let us now welcome Prashanjit.
Hello everyone, I'm Sahil from IIT Delhi. I'm going to present my work on lifelong learning to solve mixed integer programs. So in this work, we focus on learning to solve NP-hard problems using the instances of those problems. And we show how learning to solve these problems can actually help reduce the running time of ILP solvers for a variety of NP-hard problems. And then we focus on a streaming scenario where the training data to train these models appears in a sequential fashion over time. And the training also happens sequentially. And then we develop a model which can help us in reducing the catastrophic forgetting. So hope to see you at my poster. Thank you.
Thank you, Sahil. Okay, let us now welcome Abhinav.
Hi, I am Abhinav from IIT Kanpur. So in this work, we specifically study the common sense aspect of natural language, which is some implicit knowledge that you have inherently to understand language. So in example shown above, you can see if a person says, I took a flight on Thursday, you immediately understand what might have happened on Thursday. Things like he might have booked tickets, went to the airport, getting your boarding pass, and then boarded the plane. So all this implicit knowledge turns out is not learned in a supervised manner, and humans learn it via experiencing this thing multiple times. So in this work, we show whether this thing can be learned by algorithms as well via reinforcement learning. So we develop a framework for that. Thank you.
Okay, thank you, Abhinav. Next is Shweta.
Hello all, I'm Shweta from IISc, and today I'll be discussing our work called Scope Buffered Persistency Model for GPUs, published in ASPLOS 2023. Prior work shows that multiple applications can benefit from both the persistence provided by persistent memories and the parallelism provided by GPUs. These include applications like GPU-accelerated persistent key-value stores and checkpointing for long-running DNN kernels. However, these works do not define a persistency model. A persistency model describes the order in which writes to the persistent memory become durable. While a plethora of work has been done in defining and describing persistency model for CPUs, these often do not scale well for the highly parallel GPU architecture. To this end, we propose scoped buffered release persistency model for GPUs. To learn more about this, please visit my poster. Thank you.
Thank you, Sweta. Let us now welcome Simran.
Hello all, this is Simran from IIT Madras. So my poster is about a work on broadcast trace and revoke which appeared last year at Eurocrypt. So to give you a brief idea about the primitive, so imagine a content provider who wants to share some data with its subscribed users. To do so, what it does is issues a user-specific secret key using which the users can access the data. Now imagine that one of these users turn out to be malicious and sells these keys for their personal gains. Then the guarantee is that the content provider can trace back to such users and revoke their functionality. To more about this, please visit my poster.
Thank you, Simran. So we are almost done. Dilay, Vivek, and Yash, just come closer, and we are going to start with Dilay.
Okay. Good morning, everyone. This is Dilay Parmar, currently a final year PhD student and a scientific officer at SVNIT Surat. I primarily work on designing novel location privacy enhancement techniques for the edge envision environment. What do we mean by location-based services? Location-based services are type of applications which requires location information of users in providing services. Google Maps, Strava are some of the examples of location-based services. But if you provide your location information, at that time your privacy can be breached, okay? Because location information can act as a quasi-identifier for the user. So in order to preserve the privacy, dummy generation-based technique is one of the technique. However, this state-of-art location privacy technique suffers from certain issues, and there are certain attacks. So we overcome these attacks in our work. And if you are interested to know more, please visit at our poster. Thank you.
Thank you. Okay, we have next Vivek.
Yeah, hello all. I'm Vivek Shahare from IIT Dharwad. So this work was presented in SPA 23, and it will be talk about the unbalanced unlock situations in the popular lock. So we have to remedize that, analyze that, and then we come up with the performance measurement for that. So we found out that there were no performance penalty in the remedies that we propose for the popular locks over here. Yeah, thank you. For more detail, you can drop by my poster, and I'll happy to take your questions. Thank you.
Thank you, Vivek. Then Yash.
Hi everyone. So my name is Yash, and I'm from IIT Delhi. So coming on to the problem statement, so if you can see, Archive combinedly receives like 15,000 submissions monthly, and videolectures.net and underline kind of receives 5,000 submissions monthly. So it's kind of tedious to go through all the submission, and you have to figure out which ones to read and which ones to ignore. So well, for that you can always go through the abstract or the video synopsis, but sometimes it's very long, too informative, or it's time consuming. So how about we generate TLDRs, like a 2-line summary which can give you an overview of what the video or what the paper is talking about. So now how to generate those TLDRs? Let's discuss that over post break. Thank you.
Okay, so this brings us to the end of the lightning talk session. And thank you for bringing up this beautiful collection of works. And next up is the ECR talk. So we're going to start with that. Thank you once again, and continue to enjoy ARCS.